Okay, let's talk about the 1.5 partitions of sets. All right, here's the definition. All right, S, which is a subset of the power set of A, which just means that the S is going to be a collection of some subsets of A. All right, and this guy is called the partition of A if it satisfies these following three conditions. All right, first condition is if you look at each element of this partition, so for all element x in this partition S, each element has to be a non-empty set. So make sure that there is no empty set. Right? Second condition, if you pick any elements, say x and y, from this partition, from this set S, right? They are either identical sets, so x equals y, right? If they are not identical, they must be disjoint. So if you look at the intersection of two sets, it must be in an empty set, right? And last condition, if you put together all the elements in S, so each element is a set, so we take the union of all the sets in this partition, and they basically add up to the entire set A. Alright, a partition is actually a very simple concept, but these three characteristics will make it a partition. So here's what we're doing. So let's say this is set A, which has 1, 2, 3, 4, 5, 6. Right? Partition is simply doing this. All right, we're gonna make a subgroup. All right, so maybe I'm including 1, 4, 5, and to make up a subgroup. Maybe second subgroup might be just 2 by itself, and then third subgroup would have 3 and 6 in it. So which is actually listed here. Right, S1. Right, first subgroup would have 1, 4, and 5, and a second subgroup has 2, and third subgroup would have 3 and 6. All right, so let's make sure that this satisfies the condition. So let's list so condition number 1, and the condition number 2, and the condition number 3. All right, let's check the first one. All right, so every single subgroup has to be non-empty. So you can see that this is not empty, this is not empty, this is not empty. So it satisfies condition number 1. All right, number 2. Right, so it has to be pairwise disjoint. So if you pick any subgroup, they cannot share any element. You can see that. Actually, here you can see that 1, 4, 5, 2, and 3, 6. None of them share anything. So you can see that it's satisfied here. And third condition, it has to cover the entire set A. So you have to have 1, 2, 3, 4, 5, 6. You can see that 1, 2, 3, 4, 5, 6. Everyone's covered. So it is covered, satisfied. So therefore, S1 is a partition. Right? Let's check the second one. Right off the bat, that we notice a problem. So here we see an empty set here. So condition number 1 is actually violated already, right? For the fun of it, let's look at the other two. You look at any two subgroup, and they are pairwise disjoint. So number 2 is okay. And number 3, does it cover the entire set A? 1, 2, 3, 4, 5, 6. So everyone's covered, but the condition 1 is violated. So S2 is not a partition. Right? How about number S3? Right? You can see that here there is no empty set, so you can see that condition number 1 is satisfied. But second one, pairwise disjoint. But do you look at the first subgroup and the second subgroup, there is a common element 4. So therefore, they are not. It is not pairwise disjoint. So condition 2 is violated. Right? Let's look at 3. Does it cover everything? 1, 2, 3, 4, 5, 6. So number 3, condition number 3 is satisfied. Right? Therefore, S3, because condition 2, number 2 is violated, it's not a partition. All right, the last one, right? There's no empty sets, so condition number 1 is satisfied. Right? They pairwise disjoint. You can see that the 1, 2, 4, 5, 6, there's no common element. So condition number 2 is satisfied. But the last one, you can see that you have 1, 2, and misses 3, 4, 5, 6. So 3 is missing. So condition number 3 is violated. Right? Which means that S4 is not a partition. All right, that's it. I hope that this was clear.